Several things to say before we begin. It's an absolute joy to see the children here, children of all sorts of ages. Please don't feel this is a formal lecture at all. If children are noisy or disruptive, please don't worry about it. It's absolutely fine. We're going to be talking about half an hour or so, people are going to get them down. If there's a bit of noise, please don't worry, I will speak over it. Parents in particular, please don't worry about that. Children, if you have any questions at all, you don't believe what I'm saying, you think it's funny, then please put your hand up and say, it's funny. Or if you've got a question, then please ask me a question. It's absolutely fine to do that. In fact, I would like you to ask questions if you'd like to do that. And if you don't want to ask a question in the middle of the talk, then please come up at the end and ask me a question, and I will very happily do that for you. What am I going to do? We've got about 30 or 40 minutes, we'll see how it goes, and I'm going to do this for you. I am going to change your lives. Wow. Yes, I'm going to change your lives. When you leave this lecture theatre, this little place here, you will be a different person. You will see the world in a different way. And if you don't, then you can get your money back from the board. I'm going to give you, in particular children, I'm going to give you molecular goggles. I don't know if you've got molecular goggles. Do you put your molecular goggles on, children, to do that? Yes. Molecular goggles. Molecular contact lenses. Yes, some adults are doing this. This worries me slightly, but you can leave now. Yes. So children, we're going to molecular goggles, and I'm going to get you to see things in terms of molecules. In fact, I'm going to get you to do this now. I want you to turn to the person next to you and stroke them and feel them. Yes. That's everybody, by the way. Anyone above 18 can give this a go. Just remember we live in a land of laws as well. So just kind of a little feel. That's a little feel. And now, what do you tell me? What do you feel? What do you feel? Hands up. What do you feel? Yes, young man. What do you feel? Jeans. Okay, that's fine by me. What do you feel?
It's really soft.
It's really soft. I like that. What else? Tickly. Does it feel tickly? What else do you feel? Yes, young man, right in the back. Can you say it again, please?
Makeup.
Makeup. You feel makeup? Yes. Okay. Right. And yes, what do you feel? You feel your brother? Is he your brother? He's smooth. Your brother's smooth. I wish I could say that about my brother. Yes. With a smiley face on your t-shirt. I want a t-shirt like that. Warm. Shall I tell you what I feel? I'm not going to do this. I'll feel myself just in case I get trouble. Right. Here I feel molecules. I see kind of long, thin molecules: carbon, hydrogen, oxygen, nitrogen, sulfur. And you say, "Oh, Paul, that's such a sad place to be. Why would you want to be by that?" I tell you, when you do that, and you do that with everyday things around you, your brother, your sisters, your mums, your dads, your chairs, food, chocolate, then my goodness me, it's a great thing to do. And we're going to be doing a bit of that. In fact, I'm going to get you to close your eyes, and I want you to imagine. I wonder what happens when you close your eyes and you think about scientists. I have to say, but I'm going to stop here. Adults, you're all got your eyes shut like this. And all the children have got their eyes wide open. I say, yeah, what do you imagine as what do you imagine a scientist is? I wonder if it's like this. This is what you imagine a scientist to be. Here, watch this.
Hello there. This is all Cedar. I just was experimenting with fireworks for Halloween. And I think I've perfected the mixture with sulfur, using some potassium, magnesium. So when I like this, and it should just sparkle like that. That's perfectly fine. Actually, I think I'll turn the light up so it shows up better. Let's try this out.
Is that what you think a scientist is? Goes around blowing things up? No. Some people do. In fact, I should tell you, the last time I gave a lecture in this lecture theatre, I set fire to my trousers accidentally. That was an incident, I can tell you. So scientists are sometimes like that, and sometimes we do make things go bang and flash, but a lot of the time we spend our time thinking about the world around us and trying to understand it in a particular way. And we do try to make it a better place. And that's partly why we're scientists. So today we're going to do chocolate. So I told you that sometimes you think that scientists look like this. Yeah. You like that one. That's what sometimes you think scientists look like. But let's see if I can change your mind. Now I'm going to give you a little science test. Just a little one, right? And I'm going to show you some molecular formulae. And I'd like you to, I'd like you to think about what they are. And if you know what they are, I want you to put your hand up. So the first one. Oh, now. Let's see if you know what that one is. Yes, young man, what's that? Water. Well done, it's water. H2O. Yes? Next one. Let's see. Yes, what do you think? Carbon dioxide, correct. Carbon dioxide, we're all breathing out carbon dioxide. By the way, carbon dioxide is the molecule of the decade, absolutely critical. Next one, parents, you'll know this one. Let's see if the children know this one first. Quite a few parents sitting on their hands. Yes, I know the adults may well know this. I know. Let's see, yes, do you know? Ethanol, yes. Ethanol, yes, that's the stuff in alcohol, that's the dizzy juice, ethanol, C2H5. By the way, all the things I'm going to show you, you know, that come across in everyday life. Next one. Can I just say, that I've been 3 lectures, this is the third one. In the first lecture, an 8-year-old got the correct answer to this one. Just to make you feel bad. Now all the children, quite a lot of children got their hands up, lots of the adults are looking blank, and this young man here had his hand up first. What do you think it is? A chocolate? Oh, it's a very good suggestion, but no. No, but very, very good suggestion. Yes, please. I'm sorry. Is it a person? The answer is yes. That's the chemical formula of a human being. That's the chemical formula of a human being. Can you believe it? And when I see a human being, that's what I'm thinking. I'm thinking C6660, S selenium 0.000001. Yeah, I know. It's because, I'll tell you this, because those numbers and those elements, that combination, if it's slightly out, then it leads to all sorts of sickness and disease and health issues, which as scientists we can solve. I just shared that. Okay, next one. So what is chemistry? Let's go and look on the web. First definition. Chemistry, the physical science of the properties of the elementary and compound substances and the laws of combination action upon one another. Boring! Next definition. Chemistry, the science of mixing different substances together for entertainment value. The louder the bang, the better. It's very similar to cooking, but never lick the spoon. Today, we're going to lick the spoon. We're actually going to lick the spoon today. We're going to do chemistry, and we're going to lick the spoon. And I'm going to do 3 things with you. 3 things. I'm going to talk about chocolate. I'm going to say, does chocolate make you feel good? Is chocolate healthy for you? No. And then lastly, there's the 3 questions. And then lastly, can I make a better chocolate? Can I make, in front of you today, this crowd in York, a chocolate like you've never tasted before in your life?
Yes.
I'm going to say this to everybody, and with a degree of scientific seriousness, by the way, that today we're going to try something which, as far as we can see, has never been done before, and it will lead to a chocolate that will be sensational. Yeah, those few that we're going to test on, it will transform your views of chocolate. I'm just going to equip you with a tiny amount of science to do that, and we're going to do that today in front of you. So that's quite a challenge. So, okay, first question: what's in chocolate? By the way, chocolate is found in cocoa beans on plants. Yeah, and that's a cocoa bean right there. That's where it comes from. And by the way, the plant produces that as a seed to make itself grow again. What's in that cocoa? What's in there? Here we go. If you analyse it, it's about 55% fat. That, by the way, is the bad bit for you. Let's see what else. About 31% carbohydrate, that's sugar. That gives you energy. About 11% protein. That just kind of keeps the seed going. But look, the next one. A molecule, or set of molecules called polyphenols. Can we say that? Polyphenols, right? Polyphenols. Why do plants produce polyphenols? All plants. They produce them, polyphenols, to stop them getting sunburned. Can you believe that? To protect them from the outside. To give them, to stop insects eating them. They make these very unusual class of molecules called polyphenols. And it turns out these polyphenols have got fantastic properties. I'm going to look at one or two of those. And then there's a little group there called minerals, which we're not going to be very interested in, but that's what's in your chocolate bar. If you were to look at your chocolate with molecular eyes, that's what you'd be seeing. And as we do that, we can now start to answer some of these questions that I posed to you. Okay, next slide. So, does chocolate make me feel good? It's very interesting. Lots of people go, oh yeah. Why would you even suggest it? Well, what is the feel-good molecule? What do scientists know about the feel-good molecule? We go to the next slide. If you were another molecule, and you were looking at other molecules, this is what you'd see. This is how another molecule would look. You see those kind of white bits, and those blue bits, and the red bits, and the yellow bits, and the grey bits. That's how another molecule looks, kind of chubby. And that molecule there, I'm going to tell you what it is. It's a molecule called oxytocin. It is the cuddle molecule. Children, if you cuddle your mum or your dad, that molecule is released in your bloodstream. It makes you feel good. It makes you feel good. Yeah? When you're in love, slightly older people, that molecule is released in high amounts. And it gives you this buzz of feeling love. You actually feel heady. You feel euphoric. You feel great. And by the way, that molecule is at high concentration for about, when you fall in love, for about 18 months, 2 years, and then it falls away. Oh boy, does it disappear. And in the next 40 years, it's down at the bottom, right? It is true. This powerful molecule, oxytocin, generates these real deep sensations of well-being and of rapture and excitement. These are fantastically powerful hormones. And by the way, children, look this up when you go home, put it into Google and see what comes back at you. It's really, really interesting. The question is this. Oh, by the way, the kind of squiggles at the top left there is how chemists draw their molecules. But the thing at the bottom, the colour thing, is how molecules, apart from the colour, really look to the molecule. So here's the question. When the plant makes that cocoa bean, does it put oxytocin in chocolate? When you eat chocolate, is oxytocin the in-love molecule? Is it in chocolate? In other words, is chocolate an aphrodisiac? So let's do a little poll here. Who believes? Hands up. Who believes that oxytocin, the molecule oxytocin, is in chocolate? Hands up. Does it make you feel like you're in love? Oh, no. Does it make you that? Who believes that oxytocin is not in chocolate? Hands up. Oh, very, very interesting. So there's definitely people who believe that they feel like they're being cuddled or in love after they've eaten chocolate, and there are people that think that they don't. Well, I shall tell you this. The truth is, there is no oxytocin in chocolate. None whatsoever. So it's a myth that it's an aphrodisiac. It's a myth that it makes you feel like you're in love. Does it make you feel good, though? Does chocolate? Who believes? Hands up if you think chocolate makes you feel good. Yeah. Well, it's really interesting. It's really interesting because in chocolate there's some small molecules. Next slide. And I'll show you. This is oxytocin at the bottom. I've just drawn it in this squiggle form. At the top, the line. This is how chemists draw their molecules. They draw them in lines. And there's a little molecule there called dopamine. Now, dopamine. Next slide. Next slide. Oh no, not that one. Next one. In your brain, if you can everyone touch their brains? Everyone touch their brains. Ooh. In your brain, if you were to have your molecular goggles on, put your molecular goggles on, put them on. Yeah. If you see your molecular goggles, and you look in your brain, you would see a bunch of locks. Locks. They look like locks. And only certain keys fit into those locks. Only certain molecular keys, right? And when they go into those locks, they make your brain go, whoa. They send out signals. And some of those locks would make you feel good. And one of those locks is the dopamine lock. It's very similar to serotonin, which you may have heard of. And they're actually a class of molecules, neurotransmitters in your brain, which if you fill the lock with the right key, then you feel good. So the question is this: are there some feel-good molecules, some mood molecules in chocolate? Let's do a little poll. Who believes there are mood molecules in chocolate? Hands up. Yes, definitely more. It's very interesting. Who believes there are no mood molecules in chocolate? The answer is, there's plenty of mood molecules in chocolate. All these polyphenols, they have an interaction with the brain. In fact, these small molecules in chocolate are key. I need 2 volunteers, just 2. Let's see. Let's have one from the back. The little, the girl in the pink. Yes, please. If you could come down, that'd be really great. Let's pick a boy as well. Yes. What's your name? Come on, Barnaby. You can be on the front. Right. Come on. They're very colourful. Right. Some of these small molecules. This is Barnaby. And what's your name?
Lauren.
Lauren or Lauren? Lauren. Okay, Lauren and Barnaby. What do you think of the audience? What do you think? You're very nervous now, aren't you? No, tell me what you think of the audience. They look pretty, they look not pretty, they look nice, friendly, colourful. Good answer. You'll be a politician, right? Right, we're going to do an experiment. We're going to do this really good experiment. Now, have you ever thought about chocolate? Here's a bunch of chocolate, and let's see what it is. I got it from Sainsbury's this morning. It is Belgian Fair Trade dark chocolate bought on the university account. Under some weird code, right? We're going to give this a go. We're going to taste some of these molecules. We're going to taste it in a particular way, because I've already told you there are big molecules in there and there's small molecules in there. Funny thing about small molecules is that when you heat them up in your mouth, they distill, they turn into gas. So we're going to try this, and I'm going to try a very interesting experiment. Oh, I forgot to say, whenever we do experiments in chemistry, we have to wear safety specs, so you usually put those on there. And there. Put my special ones here. Okay, so I'm going to show you how to do the experiment first of all, and then I'm going to get you to do it. So you take the chocolate, and you do it, by the way folks, do this at home. You can do this with anything. Fruit is particularly good, and it's well worth a try. And this is what you do. You hold your nose. Right? You don't have to do it, right? You have to just do it. And then you eat, watch me folks, and then you eat. And breathe, just remember to breathe. And as you're eating while you're holding your nose, you taste. Right? Then you swallow, and you release your nose. And you taste again. And we're going to do that with Barnaby and Lauren. We need to small amount of chocolate. So a bit of lump for you. Hold your nose. Wait for it. Hold your nose. Okay, you look at each other. Now, can you put it in your mouth and eat it while holding your nose? Chew it. Chew it. Keep chewing. Look at the concentration, folks. Look at this. This is science. This is science in action for you. Keep eating. Keep holding your nose. Remember to breathe. Don't go blue. Right, and then swallow and release your nose. And the question is, what? Do you notice a taste difference when you release your nose? Oh, you're so good. But what do you notice? Quite hard to describe, isn't it? Oh, brilliant. Let me just tell you what they said. They said when they released their nose, they got this strong burst, and then Lauren said it tasted bitter. Perfect. Perfect. Round of applause for you two. What happened? And please try it at home. And strawberries for reason are the best. I don't know why. And you will be amazed. What will happen is as you hold it, come in, no problem. I don't know how you like. As you hold it in your nose, what happens is you block the airways. And when you eat food, 2 things happen. One, the big molecules, because they're not volatile, stay on your tongue. The small molecules, like dopamine and vanilla in particular in chocolate, distill up into your nose and they trigger the lock receptors in your nose, which then goes to your brain and goes, oh, that tastes nice. But you cannot taste anything unless those nose molecules have gone up there. So if you hold your nose, then you don't taste anything on your tongue. And as soon as you release your nose, you turn on those receptors like the keys going into the lock, and your brain turns on, literally your brain turns on, and you feel the taste in both your mouth and your nose. And the secret to chocolate, the secret to chocolate, part of why you feel good, is those small molecules that distill up. How do you tell a good chocolate then? How do you tell a good chocolate? Well, you go to Sainsbury's, right? There's this big bag of chocolate in front of you, pick them up and you sniff them. I mean, you get in trouble. Just make your way down, right? Sniff them. And the ones which have got the most volatile content, the molecules in there, will be the ones that taste the best. And that's a critical function of the roasting process. And the skill of people who make chocolate is getting that roasting process absolutely spot on. Same is true of coffee, by the way, too. Okay, next function. Next one. Is chocolate good for me? Is chocolate good for me? Okay, we're going to do an experiment. Everybody, put your hand out flat in front of you. This is fun. You're all very obedient. Look, the most obedient audience on this row we've had. Okay, now, pick up the skin on the middle of... Can you see this now? I'm going to do this in front so you can see. Here we go. Children as well, do this. I want you to pick up the skin on your middle knuckle like that. Okay, just wait for it. Keep your hand nice and flat. And watch me, when you let it go and you time how quickly it goes down. 4, 5, right. Right, so do that. I want you to time how quickly it goes down. Time how quickly it goes down. Okay. I tell you now, there's some very, very disappointed faces in the audience. If you're sitting next to a youngster, get them to do it and watch them do it.
Let go.
Yeah, if you're a youngster, this would have happened, you would let go and it would have gone flat straight away. It's a great test of biological age, not chronological age. By the way, some of us age at a quicker rate than others. It's just life, get used to it, right? It's about 1 second to 10 years. 1 second to 10 years. I know, and Michael, you were at 20 seconds, I know. It depends on hydration a little bit. I'm just under 50, and you see, when I do it, it takes about 5 seconds. 1, 2, 3, 4, 5, there we go. Done. What's going on? Here children, what we're going to do, we're going to put on our molecular goggles. And when we put on our molecular goggles and we look at our skin, what do we see when we're born, when we're young, and we're pretty, and we're energetic? What do we see? We see long, really long, thin molecules, all connected up, called elastin. And it's a bit like having a bunch of rubber bands, right? And you can imagine long rubber bands, and that's what your skin's made up of. As you go through life, though, radicals principally, basically the oxygen in the air, breaks up these long, thin molecules into little short ones. And, to put a scientific term on it, your skin goes saggy. Why am I telling you all this? Are there molecules which can interfere with this process? Can they get in the way? Can they stop those long, thin molecules being chopped up? Will they react with the oxygen radicals before you do? Next slide. If you've got a smartphone with you, or a pen and paper maybe, note this name down, Resveratrol. Resveratrol. You can look it up now on your smartphone. I don't mind. Resveratrol. There's a huge debate about something called Resveratrol. Why is there a huge debate? There's a huge debate. You should all reach your feet first. Because it's thought to interfere with this radical process. It is thought to stop, to some extent, this reaction in your skin and elsewhere. Resveratrol is found significantly, adults, in wine. He smiles, I like it, right? Here's my question for you, children in particular. Do you believe that this molecule, resveratrol, is found in chocolate? Hands up, yes or no? Yes, who believes it is? Not many, not many. Who believes that it is not found in chocolate? Hands up. Ooh, a lot more. What's the answer? What's the answer? Resveratrol. And by the way, if you've been watching carefully, you'd have noticed that this looks very similar to that previous molecule, dopamine. Remember that one? I told you dopamine was in chocolate, didn't I? So the answer is resveratrol is in chocolate. Is in chocolate. Before you go down to the store and buy a ton of chocolate, right, can I just say it is not healthy for you so much because it's full of fat. But there is this continuing debate about the health benefits of these small components of chocolate called polyphenols. And we don't really know, but there is goodish evidence that they can lead to a healthier lifetime, and maybe the reason behind, as adults, behind the Mediterranean conundrum. Okay, next slide. Can we make a better chocolate? Well, for this I need 2 adult volunteers. Let's see. Yes, please, come down. So some children are forced in there. May I just stand here? Thank you. Thank you very much. I'm Paul. Victoria and Paul. Victoria and Paul. Too many Pauls on the stage. And I also need 2 younger volunteers as well. Yeah. Come on, why don't you come down? Let's pick someone. Young man at the back with the, yes, the blue t-shirt. Come down. Come on. Don't be worried. I'll be excited. There we go. Right. Okay. Now, can we make a better chocolate? If we were to put on our molecular goggles, what would we see in chocolate? What would we see? We would see long, thin molecules, mostly, remember I told you chocolate was mostly fat, didn't I? And fat molecules are long and thin, like this. And so we could see to chocolate, what we would see is, oh, not that. We would see these long, thin molecules. But, and Emma's done some for us there, can you just hold up, we've got some liquid chocolate there. Yeah. And when we've got liquid chocolate, all these molecules are jiggling around. So that's what we've got to do, jiggle around, come on more. They're all kind of tangled up together. This is what we would see in liquid chocolate. This is what we would see. All these molecules jiggling around, tangling up, moving around like this. That's it, you're brilliant. And then with chocolate, what we do, if you're making chocolate, you slowly cool it down. So we're going to slowly get slower. And notice what's happening. Slower there. Rolling up like this. And look. What's happened to those molecules? They've all packed together in big bundles. Can you see that? Can you see what those molecules have done in chocolate? Yeah? They've all packed together in big bundles. And let me tell you right now, that's called crystallization. Let me tell you right now that chocolate, if we were to eat it, would taste grainy, would taste gritty, would take a long time to melt on the tongue. Yeah? It would be okay, but it wouldn't be great. Can we do something else? When I say 3, we just throw them on the floor. Okay? When I say 3. Can we take liquid chocolate and instead of letting it cool down really quickly, can we just flash freeze it and freeze these molecules just as they're jiggled up, like this? 1, 2, 3, now. Can we freeze the molecules like that in chocolate? So they're solid rather than packs. They're solid, all jumbled up. That's what we're going to do. Thank you very much, you two. Thank you. So, we've not met before, have we? Not met before. This is our world first, well, world third, I have to say, in chocolate making. We're going to have a go at freezing liquid chocolate in liquid nitrogen. This is liquid nitrogen. It is dangerous. It's at minus 197 degrees C. Right, it would burn you quite badly if you got on you, but I'm going to just pour some on the floor. So as it comes out on the floor, it's going to evaporate immediately. Yeah, and it completely, oh, I've got cold feet, right? Completely goes. So what we're going to do is we're going to take these molecules of chocolate, and all we've done, I should just say, we've taken, you can taste this in a bit, we're going to take this normal chocolate from Sainsbury's, this Belgian Fair Trade dark chocolate, bought on a university account. We've liquefied it, so that's going to be our control experiment, and we're going to, and there's the liquid in there, and we're going to flash freeze it. So all those molecules all jiggling around, all jiggling around, all jiggling around, all jiggling around, and in we go, plonk. So we'll just snap freeze those molecules, like throwing them on the floor. Yeah, they don't get time to all bundle up into big bundles. They can't form crystals. It's impossible. So in here should be all those fat molecules jumbled up. And by the way, if you are a chocolatier, the thing you look for in a chocolate, a beautifully tempered chocolate, is a beautifully shiny surface. That's a sign of a beautiful chocolate. And chocolatiers, they cool it down, heat it up, cool it down, heat it up, gently cool it down, and try and get a smooth chocolate. Is that shiny?
Very.
Yes, fine, very shiny. I'm going to bring this around. I just want you to, don't touch it, just see how shiny it is. Solid shiny, tempered chocolate, just beautiful chocolate, tempered perfectly, right? So it's still very cold. Right, so what we're going to do is this, watch. I'm going to let this warm up slightly, otherwise I'll hurt you. So go around here. This is where we turn it out the mould. Beautifully shiny and tempered, right? Thank you very much. I'm going to cut it into little bits. And the reason I'm doing that, I'm just going to let it warm up a bit. Of course, it was very cold. And you've got to imagine the molecules in there. They're all jumbled up. They're all completely solid, though, frozen in time and space by that process. Right, this is where we do the experiment. So, ready? So we do the control experiment first. I'm going to give you a small. Excuse fingers. Right, and taste the chocolate, watch their faces, folks. This is the normal chocolate, watch their faces, very important. This is the control experiment. Experience the taste, right? Melt on the tongue, you get a little flash of kind of volatile molecules up into your nose. Yeah, it is a normal chocolate. And by the way, you can imagine the molecules are packed together like this in bundles, they slowly free themselves as they go on the tongue, and you get this distillation. The wonder chocolate. Right, here it is, nicely tempered. Looks like a normal chocolate, right? Completely normal. Watch their faces, Yes, you can have a bit more, yes? Tell us the difference.
Very smooth.
Very smooth, yes. Very smooth, yes. Get this intense flavour as it comes out, and it just almost doesn't touch the tongue. Ah, love. And now you're envious. What has happened? Thank you very much, by the way. Yes, you can't have any more, no. What has happened? We froze those molecules onto the ground. So in that chocolate that you guys had, when we put it back on the tongue again, those molecules melted, but they instantly melted. They didn't have to untangle, they instantly melted. And the result was, it probably didn't even touch the tongue. It was probably almost liquid before it touched the tongue. It released all the small molecules into the nose. You got this hit of taste. You got this liquidation of the chocolate on your tongue. And it would have been sensation. Just a little bit of science. Put on your molecular goggles. Put them on. See what's going on in anything, particularly chocolate, and it takes you to new places, new levels of kind of understanding. Which even here in York, we've invented a new chocolate because of a little bit of science, just a little bit. There's a little bit of chocolate left for those who are interested at the end. Thank you very much for your attention.